When dealing with equipment that requires voltages not readily available from standard electrical panels, such as the 230 volts needed for the MIG welder, a transformer is the solution. A transformer will step up or step down the available voltage to match the equipment's requirement. In this specific situation, since you have a 208 volts panel but need 230 volts, you'll need a step-up transformer to convert the 208 volts to 230 volts. It's crucial to select a transformer with an appropriate voltage and kilovolt amp rating to handle the welder's load, which is 42 amps at 230 volts. Now, regarding the seemingly odd concept of single-phase 480 volts or 208 volts, the answer lies in the utilization of a center-tap transformer. A center-tap transformer is wired such that there is a neutral wire connected to the midpoint of the secondary winding. This configuration creates two equal voltages, each being half of the total line-to-line voltage. This allows for the derivation of single-phase power from a three-phase system. Let's delve into the math and the implications of this. In a typical three-phase system, the relationship between line-to-line voltage and line-to-ground voltage is defined by the square root of 3. The line-to-line voltage equals line-to-ground voltage multiplied by the square root of 3, approximately 1.732. However, in a single-phase system derived from a center-tap transformer, the line-to-neutral voltage is simply half of the line-to-line voltage. Therefore, in a 480/277 volt system, you get 480 volts line to line and 277 volts line to ground. Similarly, with a 208/120 volt system, you have 208 volts line to line and 120 volts line to ground. The 480 volts and 208 volts single-phase power can indeed be obtained from a center-tap transformer connected to the 480/277 volts and 208/120 volts panels respectively. To elaborate further, understanding how these systems are grounded is essential for safety and proper operation. Grounding ensures a low impedance path for fault currents, facilitating the operation of overcurrent protection devices such as circuit breakers and fuses. In a center-tap transformer system, the neutral point is typically grounded, providing a reference point for voltage measurements and limiting the potential for voltage fluctuations. When installing a transformer, it's important to adhere to the National Electrical Code (NEC) guidelines. NEC Article 450 covers transformers, including their installation, ventilation, and protection. The transformer must be properly sized for the load it will serve, taking into account the inrush current that can occur when equipment starts up. Ventilation is important to prevent overheating, and overcurrent protection is necessary to protect the transformer from damage due to overload or short circuits. The selection of wiring and overcurrent protection should be based on the transformer's primary and secondary current ratings. NEC Table 450.3 provides guidance on overcurrent protection for transformers. When dealing with three-phase systems, understanding the phase relationships is crucial. In a three-phase system, the three voltages are 120 degrees apart. This phase difference allows for a smoother and more efficient delivery of power compared to single-phase systems. However, single-phase power is often more readily available and suitable for smaller loads. Furthermore, the use of variable frequency drives, or volts, can improve the efficiency and control of motors in your workshop. A volt allows you to adjust the frequency of the power supplied to the motor, which in turn controls the motor's speed. This can be particularly useful for equipment like the bandsaw and grinder, where variable speed control can enhance precision and productivity. When wiring your woodshop, it's important to use the correct wire gauge for the intended load. NEC Table 310.15 provides ampacity ratings for various wire sizes based on insulation type and ambient temperature. Undersized wiring can overheat and potentially cause a fire. It's also important to use the correct type of conduit for the wiring. Metal conduit provides better protection against physical damage and can also serve as a grounding conductor. Consider the layout of your woodshop and plan the electrical circuits accordingly. Separate circuits for lighting, receptacles, and heavy equipment will help prevent overloading and ensure reliable power. Ground fault circuit interrupters, or GFCI, protection should be provided for receptacles in damp or wet locations to protect against electric shock. Consider installing a surge protective device, or SPD, to protect sensitive electronic equipment from voltage surges. Surges can damage equipment and disrupt operations. An SPD will divert surge current to ground, preventing it from reaching the equipment. Another key aspect of electrical safety is proper bonding. Bonding ensures that all metal parts of the electrical system are electrically connected, providing a low impedance path for fault currents. This helps prevent voltage differences between metal parts, reducing the risk of electric shock. Regularly inspect your electrical system for any signs of damage or wear. Look for loose connections, frayed wiring, and damaged equipment. Address any issues promptly to prevent potential hazards. When working with electricity, always follow safe work practices. De-energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Improper electrical work can be dangerous and can also violate electrical codes. Remember that electrical codes are in place to protect people and property from electrical hazards. Adhering to these codes is essential for ensuring a safe and reliable electrical system. To summarize, when dealing with different voltage requirements, understand that transformers are your go-to solution. When you need to create single-phase power from a three-phase system, center-tap transformers can be used. Always consult the NEC and hire a qualified electrician when in doubt. By following these guidelines, you can ensure that your woodshop has a safe and reliable electrical system that meets all of your power needs. Consider the long-term power requirements of your woodshop as well. As you acquire new equipment, you may need to upgrade your electrical system to handle the increased load. Planning for future growth will help you avoid costly and disruptive upgrades later on. Regularly review your electrical panel to ensure that circuits are not overloaded. If you find that circuits are frequently tripping, it may be necessary to redistribute the load or add new circuits. Effective grounding and bonding is critical. Grounding provides a path for fault currents to flow back to the source, allowing overcurrent protection devices to trip and clear the fault. Bonding connects all metal parts of the electrical system together, preventing voltage differences and reducing the risk of electric shock. Always use the correct size and type of conductors for the intended application. Conductors must be sized to carry the expected load without overheating. The insulation must be appropriate for the voltage and temperature rating of the circuit. Avoid running extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. If you need a permanent power source, install a new receptacle. Never overload receptacles or extension cords. Overloading can cause overheating and potentially start a fire. Be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. Always follow safe work practices and use appropriate PPE. Stay informed about electrical codes and regulations. Electrical codes are constantly evolving to reflect new technologies and safety standards. Keeping up to date with the latest codes will help you ensure that your electrical system is safe and compliant. When selecting electrical equipment, choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or ALL. Listed products have been tested and certified to meet safety standards. Regularly inspect electrical equipment for any signs of damage or wear. Replace damaged equipment promptly to prevent potential hazards. Educate yourself and others about electrical safety. Understanding the basics of electricity and how to work with it safely can help prevent accidents. Remember to always disconnect power before working on electrical equipment. This is the most important safety precaution you can take. Use a voltage tester to verify that the power is off before touching any wires or components. If you are unsure about any aspect of electrical work, consult a qualified electrician. Electricity is not something to be taken lightly. Making informed decisions about electrical systems will greatly improve safety and efficiency in your woodshop.